Who of you has ever used file uploads and their web applications before? I think that's pretty much most of you. So I think it's a very common requirement. And in the Ruby ecosystem, I think we have really a lot of options. And when I compared it to other programming languages, these are really high level, which means that usually it requires very little code for the file uploads to work, or for the files to get attached. And having a lot of options can be nice, but it can also be challenging. For example, you can start investing in a library only to later realize that it doesn't adapt to your requirements later on. So today I would like to raise knowledge about the file attachment flow in general, and we'll go over some important components, some general best practices, and we'll also show some relatively new possibilities. Now, before I start, I think that most of you are probably, okay. So I'm from Croatia. I'm currently living in Czech Republic. As Matt said, I have deep interest in the Ruby ecosystem outside of Rails, and I use other Ruby web frameworks for several years now. I'm also creator of Shrine file attachment library for Ruby applications, which I have been maintaining for the past 4 years. So a lot of examples in this code will be featuring Shrine, but hopefully the knowledge will be generic enough that you can apply it to your to whichever file upload solution you are using. But before I start, I think that many of you are wondering, okay, Janko, but Rails now has active storage. Why are you literally talking about anything else? Well, I would like to help you with some comparison just so that you can put these two solutions in place. For one, active storage is coupled to Rails and Active Record, while Shrine can be used with any web framework or any persistence library. Active storage is also more of a framework, while Shrine is more of a library. So with active storage, you will get more integrated experience, but with Shrine, you will get much more control. And active storage will be more opinionated, while Shrine will provide much more features. So with that in mind, I hope we can start. So I would like to start with talking about metadata extraction and file validation. I think that's the simplest area to start with. So when a user uploads a file to your via form, you usually want to validate the file as part of user input validation. Shrine provides you common validators for common metadata, and so such as file size, MIME type, and file extension. Notice that we are validating both the MIME type and the file extension. This is because those two don't necessarily have to match. It's actually very good practice and secure practice to determine MIME type from the file content. This means, so you are able to do that because each of the popular binary files has a certain sequence of bytes, usually at the beginning of the file, which are also known as magic bytes. So these uniquely determine the MIME type. This is how, for example, desktop applications are able to determine the type of your images, even if they don't have a file extension. The most popular tool for determining MIME type from file content on Unix is the file command. And also in Ruby, we have several libraries that do that. This way, if the user tries to upload a malicious file, but tries to disguise it as a file that your application will be considered valid, then your file attachment solution would detect it if it determines the MIME type from file content. When when uploading images, it's not enough to generally to only validate file size. This is because it's possible to generate an image which is relatively small in file size but very large in dimensions. These are so-called image bombs because they can crash your image processing tool. So in addition to validating the file size, you should also constrain the maximum dimensions. It's also, you should also be able to validate and extract any custom metadata. For example, a video duration. I think it's, I didn't find other attachment solutions to be able to do this easily. Usually you would have to hook into the internals of that library in order to be able to do that. And with Ryan, this is a first-class citizen. And notice also that the validation block is not a DSL. It's evaluated on instance level, so you can use regular conditionals, regular Ruby code. It's also good practice to persist any metadata that you extract. Your file upload solution should ideally do this automatically. That way, some metadata that you might require for business logic later on, you can access without having to re-download the file from the storage. Next, I would like to talk about file processing. For file processing, like for images, the go-to solution is usually ImageMagick. And a popular Ruby gem for that is MiniMagick, which allows us to easily generate ImageMagick commands. And the most popular type of image transformation is resizing. And in our application, we might want to do different styles of resizing, depending on our requirements, on how we want the image to look like in our applications. Because this is not trivial to write in ImageMagick, you need to have some thought. File upload solutions have usually come built in with some macros to make this easier. Now, when I was creating Shrine, I couldn't reuse any of these solutions because they were built into those file upload gems. So I created a generic library that I imaginatively called image processing, which provides these macros for you. And this library you can use with Shrine or with any file attachment solution that you're using. If we look closer to the ImageMagick command that one of these resize operations generates, we'll see that it performs additional things other than the resize. For one, it makes sure that any photos that were shot sideways and that might appear sideways, that they are rotated upright. It also make sure that when after resizing, because the resizing algorithms usually leave the destination image a little bit blurry, so it applies some default sharpening filter. This is something that, for example, some image processing or some imaging desktop applications do by default. And I didn't first know about that the image is a little bit blurry, but when I saw the difference, you could really tell. And it's nice that the library that you're using takes care of this for you. Now, ImageMagick is not the only kid on the block. There is also libvips, or vips for short. If any one of you has used the Sharp node package, you might have noticed that it doesn't use ImageMagick, but it uses libvips. So the advantage is that it's also a full-featured, and it has, you can do pretty much the same things with ImageMagick, but it often has much better performance and memory usage. Because I noticed that it isn't so popular in the Ruby community, I decided to create an alternative backend to the image processing gem, and tried to keep as much of the same API as possible, so that it's the easiest to switch. And if we, for example, if we execute a script that generates some set of thumbnails for image magic, in my laptop, it takes about 2.15 seconds, and with libvips it takes almost 4 times faster, or more than 4 times faster, which is pretty cool. Because all we needed to do was change the backend name and install libvips. The miracle of general purpose libraries is reusability. So Rails 6.0 now uses image processing for inactive storage variants. That means that any benefits that I've talked about so far are available now in active storage. Now, I've talked about what tools to use, but now I would like to talk about strategies on when to perform the actual processing. The most common type of processing, especially for images, is to do it on the fly. This means that you generate URLs for thumbnails which don't exist yet. And then when they are requested, the thumbnails or like any type of files are processed dynamically and then usually cached into some CDN or storage service. The active storage approach is that that you encode the processing steps into the URL. So then when the URL is requested, the controller that takes that request then simply decodes that URL and performs the processing actions specified. Now, this is really convenient because this is all that you need to do, but active storage currently doesn't support grouping those processing steps into macros. This means that if your processing logic gets more complex, your URLs would get bigger. Shrine takes the approach of that you generate a URL for a custom transformation, and to which you can pass any custom arguments. Then you simply need to define that transformation, and you are not limited by a Ruby hash, but you have the whole block, Ruby block, so you have all the freedom to perform processing in any way that you like. And this way you can also easily extract processing into commands or services. One nice thing about this is that because the transformation names and arguments are custom, they are passed to the URL directly. So the URL for a transformation, instead of having base 64 encoded steps, it communicates what it does. Now, processing on the fly is very popular, and a lot of tools like Active Storage offer these as the only solution. But this doesn't work for any slow, long-running processing, such as video transcoding. For that, you want to trigger the processing, usually in a background job, some part in your attachment flow, and you would like to then definitely cache the image onto the record. So the processing on attachment looks in a way that you generate all of the variants, versions that you want, and then you simply trigger that somewhere as part of your attachment flow. What Shrine does differently here compared to some other solutions, such as Carrierwave or Paperclip, is that it actually stores all of the processed file data into the database, including the location and any metadata that was extracted. This means that if you need to do any processing in the background, you don't need to have some Boolean column that some Boolean flag that you switch on and off to tell you when the processing has finished. You can simply read the column and see if the processed file you want is there or not. If it's not there, then the processing is still in progress. That I think that resolves that makes it easier to be race condition free. To show that it doesn't work only for images or for some specific image processing libraries, here's an example of transcoding a video and generating a screenshot. We'll notice that this processing block that Shrine provides is like a functional transformation. There is no state that needs to be managed. You simply get the source file as the argument of the block, and then you are required to return the processed files on the output. How you're going to perform the processing is entirely up to you. People who have maybe used Shrine already might know this functionality as the versions plugin, and this has been actually rewritten for the upcoming 3.0 version of Shrine, so it will now look like this and it will be much more flexible. Now we've talked about what to do when the file gets already uploaded. But now I would like to talk about the experience, the user experience itself of uploading the file to your application. These are so-called direct uploads. And they work in a way that you take over the upload with JavaScript on the client side, and then you perform the upload there, so that way the UI is not blocked and you can display a progress bar and anything else. When I was considering solutions, how I will implement direct uploads in Shrine, Raphael, Gem, and Active Storage, they both have their own JavaScript solutions for doing this. But in Shrine, I decided that I will not take this approach because for me, this functionality is too complex, and I don't feel like I would be that I'm experienced enough, or that I don't think that I would be experienced enough to be able to write it and to maintain it well. Especially because there is so many other generic JavaScript solutions that will not have many of the bugs that my implementation would have. And when I'm talking about these other solutions, I'm not talking about any of these because I didn't find them very advanced and very easy to implement things such as direct uploads to S3. So for Shrine and for maybe other solutions that you're using, I would recommend API. So API, despite the cute name, in addition to the cute name, it is really very modular. It allows you to really customize the user experience as much as you want, and it's very popular. It's gained a lot of traction over the past year or two. What's nice is that, for example, with a single, it is composable in terms of plugins. So for example, when you load the dashboard plugin, you get the full-featured dashboard for uploading files with all of the nice user experience, such as terminating uploads or seeing the progress, seeing thumbnails and everything. And it takes care of a lot of things for you. But what makes API really shine for me is that you can always drop a level lower. These UI components are built out of more low-level UI components. So for example, if all you need in your application is a drag and drop field and a status bar, you can simply load those components. And that way, for example, you can style the file attachment flow in a way that's more that fits more to your application's design. And you can even just use a simple file input and just a subtle progress bar on the bottom. So you can drop any level that you want, and all of these UI components are ready for you out of the box. You don't need to write any HTML. Now, this is how the direct upload flow will look like, but where do the files actually get uploaded to? So the simplest way is to implement an upload endpoint in your application that will take uploads and simply forward the uploads to the underlying storage service. And then when the form is submitted, only the data or the JSON data about the uploaded file is submitted via the form. So the submit is instantaneous, which is the point of direct uploads. In API, for this flow, you would load the XHR upload plugin and then simply point it to the endpoint in your application. If you're using Shrine on the server side, you can mount the upload rec application in the route where you want the upload endpoint to be. And what I really like about this solution is that this upload endpoint is a rec application, which means it will work with any Ruby web framework, including Hanami, Sinatra, Roda, and any else. But it will also work well with Shrine, with Rails. Now, another popular way, which is more performant, is to do direct uploads to your cloud service. The flow for this works in a way that the client first needs to fetch the upload parameters from the application and then use these upload parameters to actually upload directly to the cloud service. This way, the client doesn't even have to know where it's uploading. It can get all of the information from the upload parameters. Then again, when the form is actually submitted, only the data about the uploaded file is submitted. What's nice is that unlike other file attachment solutions file upload solutions in JavaScript that I saw, API offers an out-of-the-box component which knows about this flow. So it will automatically make the AJAX request on the specified endpoint. And again, Shrine provides the endpoint that will retrieve the upload parameters, which you can simply mount. Now, there is one thing that for me it's exciting, is that when you are uploading larger files, it's very nice for the user to make the uploads resumable. So what do I mean by that? I mean that a simple file upload is just an HTTP request, is a single HTTP request. This means that if you are sending that HTTP request and you're writing the file content to the body, the internet connection can break. And in that case, the upload needs to be restarted from the beginning, because HTTP requests are all or nothing. Either the whole request was sent or nothing was sent. That can be a bit annoying for people maybe who have flaky internet connections, maybe in some places where the internet is not so well. And then depending on how large the files are, users might even struggle with uploading the files to your application to begin with. The solution is to split the file upload into multiple chunks. That way, you can retry only the chunk that fails, if one happens to fail. The default, the easiest solution is to do direct uploads to S3, but use its multipart upload API. This way, you still need to have, the application still needs to serve some requests to the client, but the upload goes directly to the cloud service. For that, even though it's a different solution, the setup is very similar. You again load the corresponding API plugin for doing this flow. And I've written a gem which implements the endpoints that this plugin requires in Ruby. So you can just mount them inside your application. Now, this solution is kind of, it's not very polyglot. You have the API is the only one who knows how to make this kind of requests. So it's kind of tied to JavaScript. And on the backend side, you might have limited reimplementations of these endpoints. I don't know anyone else who implemented those except the Node implementation that comes with the API package. So an alternative is to use something more generic, which a protocol called TAS.io or TAS. This is a protocol built on top of HTTP, which means that it's a specification about what headers and URLs clients need to send to each other in order to achieve resumable uploads. And because this is a generic protocol, it's built on top of HTTP, it has numerous implementations in various languages. So if you are developing a mobile application, you have a solution for that as well. And if you decide to re-implement a microservice using in another language, you will most likely have a solution for that as well. The reason why both client and server solution need to be implemented is because both need to know about this protocol. This approach works in a way that the task server implementation, which can be mounted inside your application, but it can also be separate, it acts as sort of a proxy to the storage. So in a way, it's similar to the first solution that I showed, but it implements this more complex protocol with multiple requests. Again, the solution is pretty much the similar. You again load the corresponding API plugin, and I've also written the Ruby server implementation because at the time when I wanted to support resumable uploads, the existing Ruby implementation was very outdated and was tied to event machine. So I wanted to show you a demo how the resumable uploads look like. Notice that API's status bar, it detected that we are using a resumable solution, so it displayed the pause button, which when we click, it will terminate the request. Let's say that this means that the connection broke, but when we resume it, the server will tell the client how much it has saved, and the upload will be able to continue. This even works if we need to completely terminate the upload. For example, this can happen if we are changing a location. And in that way, if we re-upload the file again, both client and server will remember where it stopped, and then the upload will be able to finish. So to recap, you should validate files and persist any extracted metadata. You should have the option to process either attachment or on the fly, because you might have files that require both. For images, I recommend using the image processing gem. You should also add direct uploads, and for Shrine and for other solutions, I would recommend API if possible. And you can do either simple uploads to your app or to the cloud, or resumable uploads also directly to S3 or using the TAS.io protocol. Here are some links about the projects that I talked about, and that is it from me. Thank you.